Good morning, my dear students. Today I am going to discuss D and F block elements. I am Dr.R.G, Professor of Chemistry, who is taking class for you. So first, let me discuss the general characteristics of transition elements, that is D block elements. The D block elements of periodic table contains the elements of the groups 3 to 12, in which the d orbitals are progressively filled in each of the 4 long periods. These elements are called D block elements or transition elements. Why we are calling it as transition elements? Because all the properties are between the alkali and alkali metals and P block element, that is S block element and B block elements. In between this is present, it is called the transition elements. There are mainly 3 series of transition metals. We will call it a 3D series, that is first transition series, scandium to zinc. 4D series, yttrium and cadmium, that is, and 5D series, lanthanum and mercury. The 4th 6D series, which begins actinium, is still incomplete. The elements constituting the F block elements are those in which 4f and 5f orbitals are progressively filled in the latter 2 long periods, where these elements are called F block elements. They are placed separately below the long form of periodic table, also known as inner transition elements. Kindly follow. D block elements are called transition elements. F block elements are called inner transition elements. The 2 series of inner transition elements are metals. 4f and 5f are known as lanthanoids and actinoids. So, let me concentrate first the general characteristic of transition elements, that is D block elements. I will concentrate first. That is transition elements, I will concentrate. The physical and chemical properties. Number 1, electronic configuration. Number 2, nature of metals or metallic character. Number 3, melting and boiling points. Number 4, atomic and ionic size. Number 5, atomic volume and density. 6, ionization energy. Number 7, oxidation states. Number 8, magnetic properties. Number 9, formation of colored ions. Number 10, formation of complexes. 11, reactivity. 12, catalytic properties. 13, formation of interstitial compounds. And finally, formation of alloys. So we are going to discuss individually in detail. Please follow. So question can be asked only from this general characteristic of transition elements. The first, let me discuss the electronic configuration. Kindly follow. All the elements of transition series exhibit, this is the general electronic configuration, n-1d 1 to 10, ns 1 to 2, electronic configuration. The configuration of the elements It is from scandium to zinc are successively filled in 3D orbital. My dear students, here one important thing I have to give, you have to memorize this order because most of the questions are asked only from first transition series, second and third transition series they will not ask generally. So scandium to zinc, you must know the atomic number, electronic configuration as well as the name of the element. So let me write, you can just kindly follow. The first one is scandium. That is actually, it is starting from that particular series, scandium, titanium, vanadium, chromium, manganese, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. These are the 10 elements, kindly follow. Just see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here, what is the electronic configuration? Here D1, S2. So let me leave S2 because I will say D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. So this is progressively, kindly follow D10, kindly follow. So scandium D1, titanium D2, vanadium D3, chromium D4, manganese D5, iron D6, cobalt D7, nickel D8, copper D9 and zinc D10. So this is the order. Easily you can memorize and you can keep that. So what you must know, this electronic configuration, we know the atomic number if you want, this is starting from, actually it is 21 actually. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Zinc is 30. So this is the main idea. So here one important information I will give. According to the stable electronic configuration, that is half-filled and completely filled d orbital is more stable. So chromium and copper, you should be careful. So in the case of chromium, the configuration will be instead of D4, it will be D5S1. Here copper D10S1. Kindly follow. So this is the only thing you have to memorize. So first you remember this, then you just have it in mind, chromium and copper exception. So D5S1, copper D10S1. Kindly follow. So let me proceed. So from scandium to zinc are successfully filled in 3D orbital. I have explained very well. You have to memorize. The half-filled and completely filled d orbital gain extra stability. I told you half-filled chromium, completely filled copper, and are favored wherever possible. Okay. Second important characteristic, nature of metals or metallic character. All the transition elements have high tensile strength, ductility, malleability, high thermal and electrical conductivity and metallic luster. In general, greater the number of valence electrons, stronger the bonding. Here, except zinc, cadmium, mercury and manganese, they have one or more typical metallic structure at a normal temperature. This is we have to think of solid state. So except zinc, cadmium, mercury and manganese, they have one or more typical metallic structure at normal temperature. Please follow. The third one, under the general characteristics, melting and boiling point, that is physical properties. The D block elements have high melting and boiling points, which are very high when compared to S block and P block elements. Kindly follow. The D block elements have a high melting and boiling point, which are very high when compared to S block and P block elements. The melting point and boiling point increases first, passes through a maximum and then steadily decreases across any transition series. This is due to maximum number of unpaired d electron available for bonding. Kindly follow. Then, atomic and ionic size. Atomic and ionic radius of first transition series decrease with increasing atomic number. When you move across the period, kindly follow, generally atomic radius decreases. So same way here, atomic or ionic radius decrease with increase in atomic number, and after reaching a minimum again increases. Kindly follow. This is the important information regarding transition series, first transition series. This is because an increase in atomic number, the number of nuclear charge increases, which pulls the electronic cloud inward, resulting in decrease of atomic radius. However, this decrease is not, however, regular. Kindly follow. Depending upon the electronic configuration, it varies. Half field and completely field like that. This can be explained in terms of screening effect. Kindly follow. We have already discussed under the periodic classification properties, what is screening effect, what is the effective nuclear charge. We have discussed very clearly. If you have any doubt, you kindly refer. Successive addition of d electron screen the outer 4s electrons from the inward pull. Kindly follow. So it is normally 3d 1 to 10, 4s2. So 4s2 is the outer and 3d is the inner. So when we are filling up electrons in the first transition series, actually it is filled only in d 1 to 10. So what is happening now? It is protecting the 4s2 electron. Screens the outer 4s electron from the inward nuclear pull. So nuclear in the inside the nucleus, that is proton, which is pulling the electronic cloud. But this is protected by the 3d electrons. Due to this screening, the effective nuclear charge increases only slightly. Effective nuclear charge increases only slightly, and the size of the electronic cloud does not therefore change much on moving from chromium to copper. Therefore, change much on moving from chromium to copper. Please follow. Now, atomic volume and atomic density. Plus atomic volume. Atomic volumes of first transition series decrease with increase in atomic number, and after reaching a minimum again increase. Like the previous case. Density of first transition series increase with increase in atomic number, and after reaching a maximum again decreases. Ionization enthalpy or energy. Ionization enthalpies of D block elements are high. Ionization energy is very high and in most cases lie between those of S and B block elements. Kindly follow. Ionization enthalpies lies between S and P block element. Ionization energy is very, very low in the S block elements. It increases across the group. So P block elements are very high. So it is lies between. Generally, the ionization energy in any transition series increases with the atomic number. Please follow. Increases with atomic number. The increase, however, is not smooth and as sharp as seen in the case of S and P block element. In S and P block element, we have seen already when we compare the general characteristic, it was sharp. But here it is not like that. Kindly follow. Generally, first ionization energy of 5D series are higher than those of 4D series, which is in turn higher than 3D series. So, 3D series are only lower ionization energy when compared to 4D and then 5D. Please remember, question can be asked. Say for example, zinc, cadmium, mercury. This is first transition, this is second transition, this is third transition. So the question can be asked, which is having higher ionization energy? As per the rule, the first ionization energy of 5D series, this is 3D, 4D and this is 5D. 5D series are higher than those of 4D, which is higher than that of 3D. So same way, copper, silver, gold. This is again the correspondingly the 3D, 4D, 5D. Kindly follow. So next, let me go for oxidation state. Very important. Most of the transition metals exhibit variable oxidation state in their compound. The reason for variable oxidation state is that these elements have incomplete d orbital. Please follow. Incomplete d orbital and the energies of n-1d and ns orbitals are fairly close to each other. Kindly follow. And because of this, what will happen? The relative stability of the different oxidation state depends upon factors such as electronic configuration, nature of bonding, stereochemistry, lattice energy, and solvation energy. Now, this is the most important. You have to memorize. Please follow. This should be memorized. Very, very important. Only copper has +1 state. Please follow. Only copper has +1 state. No other element in the transition series, first transition series, has +1 oxidation state. Except scandium, that is the first element of the first transition series, all the elements have +2 oxidation state. So +2 oxidation state is common in all the transitions, the first transition series of elements. Number 3, except copper and zinc, all elements have +3 oxidation state. Except copper and zinc, all the elements have +3 oxidation state. Kindly follow. Except scandium, copper and zinc, all the elements have +4 oxidation state. And 5. +5 oxidation state is common only in vanadium, chromium and manganese. +5 is common. And the sixth important, +6 oxidation state is common only in chromium, manganese and iron. The most important among them all, 7, +7 oxidation state is common only in manganese. For example, potassium permanganate. You take permanganate ion, in this case, +7 is the oxidation state. The only element having +7 is manganese. Please follow. So, coming for the magnetic properties, there are mainly two types of magnetic behavior observed in transition elements. They are diamagnetism and paramagnetism. What is diamagnetism and paramagnetism? When the electrons are completely paired in the d orbital, we will call it as diamagnetic. When one or more unpaired electron is present in the d orbital, we will call it as paramagnetism. Please follow. So this will call it as a paramagnetic character. A diamagnetic character can be easily determined with the help of from the compound by using a suitable formula I have already discussed. Diamagnetic substances are repelled by the applied field, while the paramagnetic substances are attracted. Kindly follow. So when I place a magnet, diamagnetic substances are repelled by the applied field, while the paramagnetic substances are attracted. Ferromagnetism, you might have studied in physics, is an extreme form of paramagnetism. That means more paramagnetic character is present, we will call it as highly paramagnetic. The character is called ferromagnetism. Please follow. Paramagnetism arises from the presence of unpaired electron. I told you D1, D2, D3, D4, D5, D6, D7, D8, D9, like that. The only two cases, the completely filled orbital and empty d orbitals are without any paramagnetic character. Each electron is having a magnetic moment, please follow, associated with its spin angular momentum. Spin angular momentum because of its rotation. And also orbital angular momentum. So when you want to calculate the magnetic moment, we have to calculate this spin angular momentum and orbital angular momentum. You have to calculate. For compounds of first transition series of elements, the contribution of orbital angular momentum effectively quenched. Quenched means is vanished, and hence there is no significance in the first transition series. So, in the first transition series, only the magnetic moment, the spin magnetic moment is present there. There is no corresponding orbital spin magnetic moment. For these elements, the magnetic moment is determined by the number of unpaired electrons and is calculated mathematically by using the spin-only formula mu equal to square root of n into n plus 2, where n is an integer starting from, we can say, 0. Kindly follow. So number of electrons here, that is n number of electrons, mu the magnetic moment in units of Bohr magneton. Say for example, first case scandium. So I have to write now 1 into 1 plus 2. Kindly follow. So 3 plus 1, 4. It is root 4 is the, you have to calculate. Like that, you have to calculate. Please follow. So that is the magnetic moment in units of Bohr magneton, that is Bm is the unit. The next, formation of colored ion. Most of the compounds of transition elements are colored in solid state and are in solution phase. Color of a substance arises due to the absorption and emission of light in visible region. Invisible region means we can say it is with GR. Kindly follow with GR. Kindly follow. So this word you have to memorize. With GR indicate violet, indigo, blue, green, yellow, orange, red. Kindly follow. So approximately it is starting from 400 to 800 nanometer or 4000 to 8000 Armstrong unit. Kindly follow. So this is the region coming in the visible region. So depending upon the region, its color may be blue, green, yellow, orange or red. So normally red means higher range, 8000 Armstrong unit. Kindly follow. So most of the compounds of transition series are colored in the solid state and or in solution phase. Color of the system arises due to the absorption and the emission of light in the visible region. What is the region? Visible region 400 to 800 nanometer or 4000 to 8000 Armstrong unit. The metal ion which have completely empty, please follow, completely empty and completely filled d orbital are colorless. So completely empty and completely filled d orbitals are colorless, whereas incompletely filled d orbitals are colored. That means d1 to d9 it is colored ions, whereas d0 and d10 are colorless. So this you have to memorize because question will be one among the following complex or metal ion is colored or colorless. Question can be asked. So this you have to memorize. Incompletely filled D1 to D9 colored, D0 and D10 is to be colorless. Please follow. Metal ion which have partially filled d orbital will show different colors depending upon the absorption and emission of energy in the visible region. It may be blue, scarlet, different colors will be there, red, orange. The color absorbed from the ions of the solution correspond to complementary color of the light absorbed in the visible region. Complementary color of the light absorbed in the visible region. Kindly follow. Here actually there is a wheel called Bunsen wheel. So that you can easily, if you draw the Bunsen wheel, kindly refer any book or any this one. So it will be just a wheel like. It can be, kindly follow, with GR. Kindly follow. This is the wheel, Bunsen wheel. Kindly follow. Suppose if the element, the ion that is present in the solution absorbs the violet color, the region of violet color means 400 to 450 or 460, that is the region nanometer. If it absorbs energy, the emission will be green color. So we are seeing it as a emitted color only we are seeing, that is green. The same way, if green is absorbed, the emission will be violet. Like this, you just see opposite, we can see. This wheel is called Bunsen wheel. From this, we can easily identify what color will be coming out from the absorption. Depending upon the absorption of light, the emission will be different. So what we are seeing is only emitted light we are seeing as a color in the visible region. Formation of complexes. Generally, all transition elements form a large number of complex compounds. Example, first one, potassium ferricyanide. We will be discussing later stage. The next topic will be coordination compound. There we will discuss IUPAC name, the property, preparation properties, everything we are discussing. Potassium ferrocyanide, tetramine copper 2 sulfate. So these are the complex compounds. This is due to the comparatively smaller sizes of metal ion and their high ionic charges and the availability of d orbital bond formation. So the formation of complex depends on mainly three factors. One is smaller size of the metal cation. Number two, high ionic charges of the complex and the availability of d orbitals for bond formation. Kindly follow. Coming for reactivity. Transition elements are less reactive due to high ionization energy and high heat of sublimation. That's why they are generally used as a catalyst. Kindly follow. Catalytic properties. Generally, transition elements are elements and their compounds show catalytic activity. A number of transition metals and their compounds are known to catalyze various reactions of industrial importance. Very, very important. In industrial, we are preparing a number of compounds where these catalysts are used. For example, suppose you want to manufacture sulfuric acid, the catalyst vanadium pentoxide. So if you want to prepare in the laboratory oxygen, MnO2 is normally used. And if you want to synthesize ammonia, Haber process, iron is used as a catalyst. We have seen already. In the case of hydrogenation of oil, that is, oil can be converted into fat. So by passing hydrogen in presence of nickel catalyst, this is happening. So it's called hardening of oil. And lastly, manufacture of chlorine, we are using copper chloride as a catalyst. So either metals or metallic compounds of transitions elements will act as a suitable catalyst. Kindly follow. Coming for interstitial compound. Interstitial compounds are those which are formed when small atom like hydrogen, carbon or nitrogen are trapped inside the crystal lattices of metal. We have already seen under the solid state interstitial compound, interstitial defects. What is the interstitial defect? We have seen. So normally, one atom of the smaller cation will occupy the interstitial in between of the metal atoms. That is called interstitial. We have discussed again as a defects of solid state. Kindly recollect that one. So here, small atom like hydrogen, carbon and nitrogen are trapped inside the crystal lattice of metals. They are usually non-stoichiometric and are neither typically ionic nor covalent. Example, TiC, titanium carbide, Mn4n, Fe3H, VH0.56 and titanium H1.7, etc. These two compounds are non-stoichiometric. It is not obeying the stoichiometric formula. Kindly follow. I hope I have completed the D block element, that is transition elements. Dear students, thank you very much for your kind cooperation. The student, you are watching for the first time my channel, Neat Chemistry by Dr.R.G. I request you kindly click like and click subscribe button to motivate me, and also share with your friends so that the aim is fulfilled. What is the aim? I started this channel, Neat Chemistry channel, to give information, theoretical as well as the the practical idea regarding the 8th students to 12th students. I have started this channel. So what I have did this when I was starting this channel, I have taken from 8th, 9th, 10th chapters, all chapters, I have included under the basic concept of chemistry. So if you see the CBSE book or other books, the syllabus is only 26 pages will be there. Only 26. But I have given more than 17 lessons or lectures I have given. So that is including starting from 8th standard, 9th and 10th. In order to have clear idea, not only for the plus 1 and plus 2 students, 8th, 9th and 10th students also, you can view the YouTube. Kindly share with your friends. This is only mainly for poor students coming from poor family. So they need not go to tuition for chemistry. Normally students feel difficulty in physics, chemistry and maths because they are problem oriented. The concept will be very, very difficult to understand. So for that case, so my point of view, as a chemistry man, I want to help chemistry. So poor student, you need not go for tuition. If you follow systematically my notes, after finishing my theory, I will come for question discussion also from previous question papers. So you can expect so that you can get easily 100 out of 100 in not only in class the board examination, but also when you are going for NEET entrance examination, you will get 180 out of 180. Definitely you will get. Kindly follow. Next. So I have one information for students who are waiting for NEET entrance examination conducted by Government of India for this academic year. That is plus 1 studying students, plus 1, plus 2 and plus 2 completed students who are waiting for NEET entrance examination for this academic year. So we are running a Vetri coaching center in Pondicherry for the last 20 years and we have our own website, Vetri.s. So if you want to see our achievement, view our achievement, go inside the home page of our Vetri.s. So one or two achievement, let me point out, other you can, by entering into Vetri.s, you can see. One, every year we are sending 10 to 20 students minimum to JIPMER Medical College. 150 to 200 students we are sending to other medical colleges. A few students are joining IIT. Hundreds of students are joining other engineering colleges. Number two, the most important achievement of us, Vetri Coaching Center achievement is, in 2003, R. Srinivasa Raghavan from Patrick School in Pondicherry got All India first rank in JIPMER. All India first rank in JIPMER in 2003 itself. See, this is our achievement. And also from the starting now up to 2000, that is 1, the first rank we are getting always. A Pondicherry first rank we are getting. Kindly follow. Everything is given in the, you can see here. The next I want to give information. The important features of Vetri.s in this pandemic condition, that is corona situations. All students are being only the online. So better you join Vetri.s. It is a low cost, only 10,000 rupees per year we are collecting for the 4 subjects. If you go for other online, it is costlier, more than 1 lakh. So what is the importance of features of Vetri.s? It has 200 video lessons, 200 unit tests. Kindly follow. First, let me explain 200 video lessons. So lessons are covered and notes will be given clearly. You can see in the video lesson. Video, you can see the notes. The classes will be handled by professor with PhD degree and teaching experience of 20 to 30 years of teaching in IIT and medical colleges, as well as BSc, MSc and MPhil and PhD students. So highly experienced and teaching experienced professors. So they will handle very easily, you can understand. Even a dull student can understand easily. And also, the importance of video lesson is when you are opening a video, say for example in this D block element and F block element, if you open, you are seeing. So the lesson you can see. Whenever any new information or new for the data, you can just touch the video, it will stop, you can note the notes, then again touch, it will run. Any number of times you can see the video. It is the facility available. The another important feature of unit tests, kindly follow, 200 unit tests are framed from 20 years of previous question papers of IIT, AIMS, AFMC, AIPMT, MSET Andhra, Delhi, Karnataka, Kerala, Tamil Nadu and Pondicherry. So, only the previous question paper we have included. Kindly follow. So what is the advantage you can ask? Because of this, we have observed for the last 6 years of NEET chemistry, NEET entrance examination conducted by Government of India, 75 to 80 questions are same question repeated. Same question, no change, directly same. So that is, you can observe only if you attend the 200 tests. The students who are attending the NEET Vigida test, they can observe that the same questions are repeated. If you want, you can verify by the site and the question paper, keeping with along with that and verify. And also, kindly follow. So, when you are attending the unit test, there is a menu called attempt. So, enter the unit, say for example, D and F block elements. Each unit test will have 2 tests, test 1 and test 2. Each one have 45 questions. So, there is a menu called attempt. You click attempt, immediately a window will open. A window will open. In the window, it will say, it will give informations. This unit has 45 questions. Each question carries 4 marks. For correct answer, 4 marks awarded. For wrong answer, -1 mark will be awarded. That is subtracted. Kindly follow. So, the total number of the time is only 45 minutes. 45 questions, 45 minutes. So, when you press attempt, you are getting this information. Then below, it will ask, are you ready? Yes or no? So, if you say yes, that is, click OK, immediately another window will open. In the window, you can see question number 1, option A, option B, option C, option D, and there are 3 menus below. What are the 3 menus? Center is complete. This you have to touch only at the end of the completion. Left side reverse and right side next. So with the help of menu next, you can go for the next question. With the help of the menu reverse, you can come to the reverse question. So there is one more information is present in here below. 1 to 45 question number only will be there. One number 1 to 45 in yellow color. Please follow. This facility is not available in any other online leading coaching center. Please follow. You can verify and see. Only Vitidata is having. So if you just suppose you are reading the question number 1, you are observing A is the correct answer. Click A. Immediately question number 1 will become green color. Question number 2 become blue color. All other questions will be in yellow color. That means whatever question you click, that will becoming green color. Suppose you are gone up to 20 questions, so 20 questions will be in green color. If you answer all the remaining will be, the 21 will be blue, all the remaining will be yellow. This facility means at any stage you can understand how many questions you answer, how many questions you have to answer, and also simultaneously clock is running, you can see the time. Please follow. This provision is not available in any online center. Okay. After completing all the 45, click complete. When you click complete, a window will open, you will get your marks. The program, kindly follow, will automatically add and subtraction will done. So for example, you are getting 160 out of 180. How 180? 45 into 4, 180. So 20 mark you are losing. So you want to know, curiosity, which question you have done mistake. So there is a provision we have given. This provision is not given in any other online coaching center. Kindly follow. Review is not available in any other online center. Kindly follow. What is that review? You click review, immediately the window will open. Question number 1 will be there. Option A, option B, option C, option D there. And below that, that is correct answer, yellow color. And here video solution. Please follow. This is it is a unique feature of Edutatus which is not available in other online leading coaching center. They are collecting more than 1 lakh. So you have answered A is the correct answer. Your answer will be in blue color. Please follow. Blue color. Correct answer will be given in yellow color. So compare these two answers. If they are same, your answer is correct. If they are different, your answer is wrong. So this verification you can done only in Edutatus, not in other online coaching. Another important characteristic, if you go for other online coaching, they will give solution. If you press solution, they will give only one word. Say for example, answer is solid, solid, liquid, liquid, like that. Or they will give 1 line or 2 line maximum typed material. Only typed material inside any one of the option. Whatever correct option, and below that they will give the answer. Below that they will type these 2 lines or 1 line. But ours is entirely different. You can verify you are correct or not, because in other online coaching you cannot say, because you have forgotten which question you answered, which question you have not answered, you cannot verify. But here you have verified your answer and compare with your correct answer. Then to no idea, you click the video solution. Immediately video will run for 10 to 15 minutes it will run. Please follow. 10 to 15 minutes depending upon the nature of questions. The professor with the PhD degree and the 20 to 30 years of experience in IIT and medical coaching will explain. You can feel classroom coaching. He will stand in front of a board. You can see him and you can see the board also. And he will read the question, he will read the option, he will start explaining definition, formula, any diagram required, any tabular column, everything he will give and then explain so that you can very easily understand the question. So what is the aim of this technique? So in future, if any question of similar type it is coming, so you can follow the same technique, you can easily solve the problem. So, if you are able to complete after joining the Edutatus, 200 tests if you complete, I can give you assurance minimum 600 to 700 you can get easily. You can get JIPM, that is medical college, especially JIPMER you can enter if you are a Pondicherry student. And even if a dull student, you can get nearly 500, minimum 500 you can get. I can give you assurance for this one. Kindly follow. So, I told you we are the low cost helpful for poor student to help poor family. How to pay 10,000 rupees? Pay 10,000 rupees in the name of Sandhi, Director of Vetri Coaching Center, Indian Bank, account number 7127194771, IFC code IDIB000P134, cell number 9894176425. It is my number, the cell number as well as WhatsApp number. Any query or any clarification, you contact me. I hope. Thank you very much for your kind cooperation. See you again in my next chapter. Bye bye.